Today's lesson is actually a review. In this lesson we're going to solve compound inequalities. This stuff you should have done in algebra, so some people may remember it more than others, but anyway, we're going to go through it and see what we do. So what exactly is a compound inequality? A compound inequality is formed when two simple inequalities are formed into one statement. So for example, if we have 14 is less than or equal to negative 2x plus 6 and negative 2x plus 6 is less than 36, we can rewrite this. We can rewrite this using a compound inequality, and this rewritten will look like 14 is less than or equal to negative 2x plus 6, which is less than 36. It's almost kind of a shortcut, and that is what a compound inequality is. How did I know that this was an inequality to begin with? A simple inequality. Inequalities have these symbols. They don't have equal signs. They have the less than or equal to, less than, greater than or equal to. And so whenever you have these two statements, you can write a compound inequality. So now on the next slide, we're actually going to go solve this compound inequality. But before we do, you might want to look at the properties for compound inequalities. These are listed on page 330 of your book. We're going to go through most of them, but there's a nice table if you want to look at them on page 330. So what we want to do in this example is to solve the inequality we saw on the first slide, and then we want to answer the question, what geometric figure does the graph represent? So let's go ahead and look at this. We see 14 is less than or equal to negative 2x plus 6 is less than 36. That's just rewriting it. Now, the first step we're going to do is we're actually going to split it up into the two single inequalities. So we have 14 is less than or equal to negative x, and then also on the right hand side you have negative 2x plus 6 is less than 36. Now we've got it split up into two inequalities, the left side and the right. Now, we can just deal with the left side and then the right side by itself, so let's go ahead and do that. We want to solve. What solve means is to get x by itself. So we're looking for that x value. Even though that these are not equal signs, we can still do the same operations. We can still add, we can still subtract, we can still multiply and divide. So that's what we're going to do. I see a plus 6, so let's do the opposite. Let's subtract 6. Subtract 6. And 14 minus 6 is 8. And then you keep this just like you would with an equal sign. It just follows straight down. It just comes on down. So we see it's less than or equal to, and now negative 2x. Alright, now we need to solve for x a little bit further. And I see you divide by negative 2. So dividing by negative 2 gives us, what is 8 divided by negative 2? It's going to be negative 4. Now, we normally would keep this less than or equal to sign and we would just put it down there. The problem is that we divided by a negative. Whenever you divide or multiply by a negative, remember you just flip the sign. So now we have negative 4 is greater than or equal to x. Alright, so we got x by itself. Awesome. And now if you looked at the properties on page 330, you would see that this statement is the same exact statement as saying that x is less than or equal to negative 4. Well, then that makes, I just like seeing x on the left hand side, but that makes sense. Because if I tell you a number is greater than or equal to x, well then x has to be less than or equal to that number. So that makes sense, and that's a property again on that table. Now let's talk about the right side. We're going to do the same stuff. Subtract 6, subtract 6, and we get negative 2x is less than 30. Solving for x again, we divide by negative 2, and see that x is, careful here, we divided by a negative. Remember, when you divide or multiply, you have to flip the sign. So instead of less than, we have greater than, and we have negative 15. Okay, So we see that x is going to be less than or equal to negative 4, or x is going to be greater than or equal to negative 5. So we did solve already. Now we just need to put it together. We can rewrite that into our compound, which would be the negative 4 is greater than or equal to x, and x is greater than negative 15. Alright, cool. This would be your solution. But then we need to answer this question of what geometric figure does the graph represent? So what we do here is we actually look at a number line. If you remember a number line, it's simply a line that represents the numbers. And we could list all the different numbers, but all we really care about are negative 15 and negative 4. And so we at least want to make sure we get those on there. So I'll put 0 as well. And this isn't going to be exactly to scale, but we'll put 0 on here. We'll get negative 4 will be about here. And then we have negative 15 in about that area. And of course you've got your different values all in here, but we're not concerned with those. You need to go ahead and graph this now. If I tell you that x is less than or equal to negative 4, that means it's got to be another negative number. So go ahead and graphing that. It can't be negative 3, it can't be negative 2 because those are greater than negative 4. So we make a circle on negative 4, but because it also includes, because it's or equal to, we have to fill that circle in. Okay? And now if we were talking about x is greater than, we would make a line this way. But we're not talking about that because we're talking about less than. So we go to the left, and going towards the left will be this way. I'm not going to go all the way because there's also a little bit more we need to see. X is also greater than negative 15. So we can make our circle on negative 15, but we notice it is not including negative 15. Because it's not including, we keep it open. Alright? And we said x is greater than, so we shade to the right. And now we continue, and you will see that whatever x value we have has to be somewhere on this red segment. And in fact, that is our answer to this question. What geometric figure does it represent? Well, that's a segment. So that's simply your answer would be a segment. And it always helps to include that number line. What other answers may you see? I'll talk about that on the next slide just for more room. So here I've listed the possible geometric figures formed by a number line. The first is a segment, and we actually looked at the segment. The segment, you have your number line, and your segment, some sort, will be represented as such. You could also have a line. Now, what a line would look like is if you have your number line, and what a line would look like is if your compound inequality told you that perhaps you are here, and it says that we are less than this value, and now here's the key word, or greater than this value. The example we did on the last slide was including the word and. It was implied because they were put together. If you see the or, then it could satisfy either the first condition or the second condition. So there's where a line would look like. And your solution, instead of like x plus 5, your answer would be all real numbers because it could be any number on this line. You also have two rays. What two rays might look like is if, again, you have your number line and you have 2 points, and two rays would look like so. They go in opposite directions. You have one ray going to the left and one going to the right. Similarly, you can have one ray with your number line, and we can do two values. And what one ray would look like if I said, well, your first value is greater than that one on the right, or it's greater than the one on the left. That would form one ray, because in all actuality, your solution is just simply to the right of this leftmost value. So these are possible geometric figures formed, just so you know, and hopefully that helps out on your homework.